I bring the chisel to my forearm, and a strip of hair simply vanishes, leaving the skin behind it smooth and without the slightest hint of irritation. This isn't a parlor trick, and it isn't some expensive brand of magic. This is carbon steel that has been pushed to a level of sharpness that most modern woodworkers only read about in glossy catalogs, but rarely achieve at their own benches. As I stand here in the morning light of my workshop, looking at the mirror polish on this cutting edge, I can't help but think back to my first few years in this trade. Back then, I was convinced, like so many others, that the quality of my work was a direct reflection of how much money I dropped on my tools. On the shelf behind me, there's a set of Japanese waterstones, still gathering dust in their plastic cases. I remember the day I bought them. I spent over $300 on those stones, believing they were the true path to mastery. I babied them. I spent hours flattening them with a diamond plate that cost another $100, obsessing over every microscopic scratch, thinking that the more complex and expensive the ritual, the better the result would be. But the reality of the workshop is far more honest and much more brutal than a marketing brochure. The method I'm going to show you today doesn't require electricity. It doesn't require a $500 slow-speed grinder, and it doesn't demand that you spend years apprenticing under a master to develop the feel. All the equipment for this setup costs less than $20, and yet the result allows a standard hardware store chisel to glide through the end grain of a piece of seasoned white oak as if it were slightly softened butter. 50 years ago, in the precision tool and die shops across America, masters who worked to tolerances of 10/1000ths of an inch used this exact approach. They didn't have the time or the inclination to buy artisan stones. They created precision edges using what was readily available on the shop floor. Today, I find myself asking why we've been told for decades that a carpenter needs an entire arsenal of specialized abrasives, stone holders, and soaking baths just to get a clean cut. The answer is as simple as it is cynical. You cannot build a marketing empire on a sheet of sandpaper and a scrap of thick glass. It isn't profitable for a manufacturer to let you know how simple physics actually is. They need to sell you complexity wrapped in a sleek, anodized aluminum box. They need repeat sales of proprietary oils and expensive lapping plates. This method is often called scary sharp, and after 20 years at the bench, I can tell you that the name earns its keep the very second you feel the tool bite into the wood. This knowledge lived for decades in closed professional circles of pattern makers and machinists until the hobbyist market convinced a whole generation that a clean cut was a privilege reserved for those with deep pockets. But the physics of an edge haven't changed since the Iron Age. Only the economics have shifted. I've spent the last 2 decades testing every system under the sun, and I keep coming back to this. It's a return to the basics that actually work in a master's hands, rather than on the pages of a high-end catalog. When I first started digging into the roots of this technique, I expected to find a clever internet hack from the early 2000s. But what I found goes much deeper, back to an era when mastery wasn't measured in views or likes, but in the actual fit of a piston or the clearance of a casting mold. We're going to strip away the marketing fluff and look at how we can turn a piece of industrial waste and some automotive supplies into the most effective sharpening system in your shop. I'm going to take you through the physical mechanics of why this works, how to set it up for pennies, and I'll share a specific trick I learned from a retired toolmaker in Michigan that doubles the life of your abrasives, something I have never seen printed in a single modern woodworking manual. We are going back to a time when the tool was a means to an end, not an object of worship, and we're going to do it with the same precision those old-timers used to build the world. When I started tracing the history of this method, I didn't find it in a dusty manual on 18th century cabinetry. Instead, I found its DNA in the high-precision world of the mid-20th century American machine shop. In the 1940s and 50s, particularly in the industrial hubs of the Midwest, there were masters known as pattern makers and tool and die machinists. These were men who lived and breathed in a world where 1/1000th of an inch was considered a sloppy margin. The pattern makers were the bridge between the designer's sketch and the final cast iron engine block. They carved the wooden forms that the metal would be poured into. If their wood joint was off by the thickness of a sheet of paper, the final metal part would be a failure. They couldn't afford artisan quirks. They needed a sharpening system that was fast, repeatable, and, above all, mathematically flat. In those shops, you wouldn't see a row of expensive, fragile natural stones. You'd see heavy steel surface plates or thick slabs of industrial glass. These men understood a fundamental truth that the modern marketing machine tries to obscure. The sharpening surface is the boss. If the surface isn't flat, the tool will never be flat. They used silicon carbide abrasive sheets, what we call wet or dry sandpaper, because it was an industrial consumable. It was cheap, it was consistent, and when it was worn out, you threw it away and put down a fresh, perfectly flat layer. They weren't being cheap, they were being precise. They understood that a sharpening stone starts to wear the very second you touch steel to it. It dishes in the center, creating a microscopic curve. For a guy making a mold for a turbine blade, a curved edge was a broken tool. The central pillar of this entire philosophy is float glass. This isn't just a fancy name for window glass. Before the 1950s, making flat glass was a nightmare of grinding and polishing. Then, the Pilkington process changed everything. They began pouring molten glass onto a bed of molten tin. Because the tin is perfectly level, the glass that floats on top of it settles into a sheet that is terrifyingly flat, often to within a few microns across its surface. When you take a piece of 10 millimeters or 12 millimeters float glass and use it as your sharpening base, you are borrowing the precision of a multi-million-dollar industrial process and putting it on your workbench for the cost of a sandwich. I remember the first time I saw a retired pattern maker in a small shop outside of Detroit set this up. He didn't have a $500 sharpening station. He had a scrap of glass salvaged from a commercial storefront and a roll of industrial abrasive. He worked with a speed that made my meditative stone sharpening look like a waste of a life. He explained it to me like this: the wood doesn't care how much you paid for the stone, it only cares about the geometry of the edge. That stuck with me for 20 years. We've been sold the idea that sharpening is a craft or a ritual that requires a special spiritual connection to the material. That's nonsense. Sharpening is a mechanical engineering task. It is the intersection of two flat planes at a specific angle. If your abrasive is on a surface that can bend or dish or wear unevenly, you are fighting the laws of physics. The old-timers didn't have time to fight physics. They had a production schedule to meet. The bridge to our modern reality is where things got twisted. In the late 80s and early 90s, as the hobbyist woodworking market exploded, companies realized they couldn't make money selling you a $5 piece of glass and a $1 sheet of sandpaper that you could buy at any auto parts store. They needed proprietary systems. They introduced the idea that unless you were using a 12,000 grit specialty stone from a specific mountain in Japan, you weren't a serious woodworker. They took a straightforward industrial process and buried it under layers of mysticism and expensive accessories. I fell for it myself. I spent years chasing the next big stone while my joints were still gapping and my end grain was still tearing. The reason this method is so relevant today is that modern tool steel like A2 or the harder CPMV series is actually very difficult to sharpen on traditional stones. They're too hard. They skid across the surface of a natural stone. But silicon carbide sandpaper? It's designed to cut through hardened steel like it's balsa wood. By returning to this forgotten industrial standard, we aren't just saving money. We are actually using a more effective technology for the materials we work with today. We are moving away from the worship of the tool and back to the mastery of the result. I realized that I'd been spending 30% of my shop time just maintaining my sharpening equipment, flattening stones, cleaning baths, truing plates. The masters of the 1940s would have laughed at me. They used their tools to build things, not to maintain the things that maintain the tools. When we lay that first sheet of 220 grit paper onto a slab of heavy glass, we're not just sharpening a chisel. We're reclaiming a standard of precision that was almost lost to the glitz of the retail market. Now, Let's move from the philosophy into the grit and the steel. The scary sharp process is a disciplined progression. It isn't about sanding a piece of metal until it looks shiny. It's about a sequence of controlled mechanical operations that build upon one another. If you skip a step or rush the foundation, the final edge will fail you within 5 minutes of hitting the wood. I've seen guys spend an hour on the fine grits trying to polish out a scratch that should have been removed at the very beginning. That's not craftsmanship. That's just stubbornness. We're going to cover 5 specific techniques that will take a dull, factory-ground chisel and turn it into a surgical instrument. The first technique is the hydraulic lock and surface preparation. You need a piece of 10 millimeters, about 3/8 inch, float glass. I prefer a piece roughly 12 by 12 inches. It's heavy enough to stay put on the bench without clamps. Before you even touch sandpaper to it, the glass must be surgically clean. I use a splash of denatured alcohol and a lint-free rag to remove every speck of dust. 1 grain of sand under your paper will create a high spot that will ruin your geometry. To attach the paper, you have 2 choices: spray adhesive or water tension. In my shop, I've moved away from adhesives because they leave a gummy residue that's a pain to clean. Instead, I use the water lock method. I take a spray bottle and mist the glass lightly. I lay the sheet of sandpaper down, silicone carbide, wet or dry variety, and use a rubber squeegee to push the air and excess water out from the center to the edges. The surface tension of that thin film of water creates a vacuum that locks the paper to the glass so tightly you'd need a putty knife to peel it up. This is critical. The paper must be absolutely flat against the glass. If there is a single air bubble or a wrinkle, the paper will pillow under the pressure of the chisel, and you will end up with a rounded, dubbed-over edge that won't cut deep. I remember trying to rush this with a piece of cheap, thin window glass and some dry paper held down with masking tape. The paper shifted mid-stroke, caught the edge of the chisel, and sliced the sheet in half while rounding my bevel into a useless curve. I had to start from scratch. Use the water, use the heavy glass, and make sure that paper is part of the surface. The second technique is the strategic progression. You aren't just moving through grits, you are removing the damage from the previous grit. For a tool in rough shape, maybe one you found at a garage sale or a new one straight from the big box store, we start at 220 grit. This is the heavy lifting stage. On the 220, your goal isn't sharpness, it's geometry. You are grinding the face until it is perfectly flat and the scratches are uniform. You'll hear it before you see it. The 220 has a coarse, rasping sound like walking on gravel. Once the entire surface of the bevel shows the same dull gray scratch pattern, you move to 400. This is where the magic starts. The sound shifts from a rasp to a hiss, then 1,000, and finally 2,000. To put this in perspective for the skeptics, 2,000 grit sandpaper has an abrasive particle size of roughly 10 microns. For comparison, a 10,000 grit Japanese water stone, which might cost you $150, is usually around 1 to 1.5 microns. By the time you finish on 2,000 grit paper, you have reached the limit of what 90% of woodworking tasks require. I've found that using water as a lubricant here is non-negotiable. It flushes away the swarf, the microscopic bits of steel and abrasive, and prevents the paper from loading up. If the paper gets black and gummy, you aren't sharpening anymore, you're just burnishing. Keep it wet, keep it clean. The third technique involves the mechanical advantage of a honing guide. I know, some old-timers brag about sharpening freehand, and I can do it too, but if I want a repeatable 5-minute edge, I use a simple Eclipse-style side-clamping jig. It costs about $15. Here is the trick for precision, the projection ruler. I have a block of wood with 2 lines marked on it. One is at 35 millimeters from the edge, the other at 40 millimeters. If the chisel sticks out 35 millimeters from the front of the jig, it sets a 30-degree angle. If it's 40 millimeters, it's 25 degrees. By using this block, I can return to the exact same angle every single time. This is where the micro bevel comes in. Instead of trying to sharpen the entire broad face of the chisel's bevel, which takes forever because you're removing so much metal, I sharpen the main bevel at 25 degrees on the coarse 220 and 400 grits. Then, I move the chisel in the jig so it sticks out only 30 millimeters, which kicks the angle up to about 32 degrees. Now, when I hit the 1000 and 2000 grit, I am only removing metal from the very tip of the edge, a tiny strip less than a millimeter wide. I can achieve a mirror polish on that tiny strip in 10 strokes, whereas polishing the whole face would take 100. It's faster, it's more efficient, and it creates a stronger edge because there's more steel backing the point. The fourth technique is the reference plane, or flattening the back. This is the most common place where beginners fail. A chisel is the intersection of two planes. If the back of your chisel isn't flat, it doesn't matter how pretty the bevel is, your edge will be jagged. I've picked up premium chisels that were hollow in the middle or twisted like a propeller. You must lay the back of the chisel perfectly flat on the glass. I start at 400 grit and work my way up to 2000. You don't need to flatten the whole back, just the first inch or two from the cutting edge. When you see a consistent mirror-like reflection that goes all the way to the corners, you know you have a true reference. I once spent 2 hours trying to figure out why a dovetail joint wasn't fitting, only to realize the back of my chisel was slightly convex. It was acting like a rocking chair, preventing me from making a straight vertical cut. Since then, the first thing I do with any new tool is marry it to the glass. The fifth and final technique is the zero grit strop. This is the transition from sharp to scary. I take a scrap of heavy vegetable tanned cowhide, about 3 inches wide and 10 inches long, and glue it to a flat board. I load the rough side of the leather with chromium oxide paste, that green waxy stuff. The particle size here is about 0.5 microns. This is equivalent to a 30,000 grit stone. The movement here is strictly trailing edge. If you push the edge into the leather, you'll cut it. You pull the chisel toward you, keeping it flat on the micro bevel. 10 strokes on the bevel, then lay it flat on its back and give it 5 strokes to wipe the burr off. The burr, or wire edge, is a microscopic ribbon of bent metal that forms during sharpening. If you don't remove it, it will fold over the first time you hit wood, and the tool will feel dull immediately. On the leather, you can feel the resistance change. It starts with a slight tackiness as it grabs the burr, and as the edge becomes perfect, the resistance disappears. The tool begins to glide as if it's floating on air. I recently compared a chisel sharpened this way against one I did on my expensive 8,000 grit Waterstone. I took a piece of end-grain walnut, a notoriously unforgiving test. The Waterstone edge was good, it left a clean surface, but the scary sharp edge, the one from the glass and the sandpaper, left a surface that looked like it had been polished with wax. There were no white crush marks in the pores of the wood. It was a clean molecular shear. When you see that result, you realize that the primitive method of the old-timers wasn't primitive at all. It was a sophisticated understanding of friction and geometry that we almost traded away for the convenience of a store-bought solution. This process isn't about the paper, it's about the absolute, unyielding flatness of the glass and the consistent, high-speed cutting action of modern industrial abrasives. It's a system that rewards patience and precision over the size of your wallet. Looking back at the decades I've spent hunched over this workbench, I see a long trail of wasted time and expensive mistakes, not because I was lazy, but because I was following the wrong map. We're all prone to believing that if a task is difficult and expensive, we must be doing it the right way. But in the world of the master craftsman, that's almost always a lie. Complexity is usually just a mask for inefficiency. Over the years, I've had to identify and kill 4 specific patterns of thought that were holding my work back, and I suspect many of you are carrying these same weights. The first, and perhaps most destructive, is the belief that pressure can compensate for a dull edge. I remember early in my career, when a chisel started to resist the wood, my instinct was to lean into it with my shoulder. I thought I was being productive by using brute force, but on a glass sharpening plate, that habit is fatal. If you apply heavy downward pressure, you create a microscopic bow wave of water and paper in front of the cutting edge. That tiny wave acts like a ramp, rounding over your perfectly flat microbevel and destroying your geometry in a single stroke. I didn't truly understand this until I started sharpening with just the tips of my fingers, applying only enough weight to maintain contact. Real sharpening isn't a wrestling match, it's a delicate, controlled glide. If you find yourself straining your muscles, it's not you that's failing, it's the abrasive. Stop, change the paper, and let the physics do the work. The second pattern is what I call the gear fallacy. For years, I hoarded elite stones like they were religious relics, thinking their price tag acted as a safety net against my own errors. I thought the stone was the master. But the glass and sandpaper method is a brutal teacher because it strips away that illusion. There is no status here, only a flat plane and a piece of steel. This method forced me to look at the real reasons my joints were gapping. It wasn't that I didn't have a 12,000 grit natural water stone, it was that my hand was tilting at the end of the stroke, or that I hadn't properly flattened the back of my tool. This is an honest method for people who want to be better masters, not just better consumers. It shifts the focus from what you own to what you can actually do. The third pattern concerns the ritual of time. There's a persistent myth that sharpening needs to be a long, meditative ordeal, that you haven't truly sharpened a tool unless you've spent 40 minutes at the sink. That isn't mastery, it's a lack of process. Once you've established your primary bevel, the actual honing process should take no more than 5 minutes from start to finish. If your 220 grit work was done correctly, you only need 10 to 12 strokes on each subsequent grit. If you're doing 50 strokes on 1,000 grit paper, you're not sharpening, you're just wearing out your supplies. Efficiency is a form of respect. Respect for your materials, your tools, and your own limited time on this earth. I've found that my best furniture wasn't made during the hours I spent sharpening, but in the hours I saved by sharpening correctly. The fourth pattern is the one-sided obsession. Most people obsess over the bevel because that's what looks sharp in photos. But a cutting edge is a line of intersection. If you ignore the back of the chisel, you are only doing 50% of the job. I used to be guilty of this. I'd polish a bevel until it shone like a mirror, but the back was still the factory-ground mess it started as. The result was an edge that looked sharp, but acted like a saw blade on a microscopic level. I had to train myself to give the back of the tool the same reverence as the front. Only when those two flat planes meet perfectly does the steel stop fighting the wood and start cooperating with it. Now, I want to share that trick I promised you, the one I learned from a man who spent 40 years in a Michigan tool and die shop. It's a tiny detail that changes the entire economy of your workshop. When you get into the high grit papers, the 1000 and 2000 grit, the paper often feels like it quits after just a few passes. Most guys think the abrasive is worn out and they toss the sheet. But the grit isn't gone, it's just loaded. The microscopic pores between the abrasive particles are packed tight with swarf, that black slurry of steel dust. To stop this, add exactly 1 drop of common dish soap to your spray bottle of water. That's it. The soap acts as a surfactant, breaking the surface tension and keeping the steel particles in suspension. Instead of embedding themselves into the paper, they float on top of the water film. I've been testing this for 3 years, and it has doubled the life of my finishing sheets. It turns a 10-cent sharpening session into a 5-cent one. It's the kind of shop floor wisdom that doesn't make it into textbooks because there's no money in it for the manufacturers. The shift from expensive, complex systems to simple, effective ones is a recurring theme in the history of craft. We saw it with the move away from natural glues to chemical ones, and we're seeing it now with the commodification of the sharpening process. But as long as there are hands willing to do the work, the real knowledge won't disappear. I've spent the better part of my life gathering these fragments of experience, and I've put the most vital of them into my book, The Forgotten Workshop. It's a collection of 100 lost woodworking skills across 171 pages, practical, hard-won knowledge that hasn't been diluted by corporate interests. You can find the link in the description below or scan the code you see on the screen. If you value this kind of no-nonsense approach to the craft, consider subscribing to the Heritage of Craft channel and hitting that bell icon. Every view and every comment helps us keep these traditional methods alive and accessible to the next generation of makers. Our next deep dive into a forgotten technology is coming up soon, and I think it's going to change the way you look at your raw materials entirely. The tools are back in their racks. The workshop is finally quiet. But the edge I've put on this steel today will still be there tomorrow morning, ready to do exactly what I ask of it. That's the real privilege of the master, not the tools he owns, but the certainty that he knows how to use them. I'll see you at the bench.